Types of bearings: rolling element bearing, ball bearing, angular contact ball bearing, self-alignment ball bearing, thrust ball bearing, roller bearing, cylindrical roller bearing, spherical roller bearing, tempered roller bearing, needle roller bearing, plane bearing, fluid bearing, hydrostatic bearing, hydrodynamic bearing, magnetic bearing, active magnetic bearing, passive magnetic bearing. Types of bearings. What is the purpose of bearings? The main purpose of bearings is to prevent direct metal-to-metal contact between two elements that are in relative motion. This prevents friction, heat generation, and ultimately, the wear and tear of parts. It also reduces energy consumption as sliding motion is replaced with low friction rolling. They also transmit the load of the rotating element to the housing. This load may be radial, axial, or a combination of both. A bearing also restricts the freedom of movement of moving parts to predefined directions as discussed above. Rolling element bearings. Rolling element bearings contain rolling elements in the shape of balls or cylinders. We know that it is easier to roll a wheel than slide it on the ground, as the magnitude of rolling friction is lower than sliding friction. The same principle is in work here. Rolling element bearings are used to facilitate the free movement of parts in rotational motion. Even when we need linear motion in applications, it is easy to convert rotational motion to sliding motion. Consider an escalator or a conveyor. Even though the motion is linear, it is powered by rollers that are driven by motors. Another example is a reciprocating pump that can convert rotational energy from a motor into translational motion with the help of linkages. In each of these applications, ball bearings are used to support motor shafts as well as shafts of other rollers in the assembly. Rolling elements carry the load without much friction, as the sliding friction is replaced with rolling friction. Rolling element bearings can be subdivided into two major types: ball bearings and roller bearings. Ball bearings. Ball bearings are one of the most common types of bearing classes used. It consists of a row of balls as rolling elements. They are trapped between two annulus-shaped metal pieces. These metal pieces are known as races. The inner race is free to rotate while the outer race is stationary. Ball bearings provide very low friction during rolling but have limited load carrying capacity. This is because of the small area of contact between the balls and the races. They can support axial loads in two directions besides radial loads. Ball bearings are used for controlling oscillatory and rotational motion. For example, in electrical motors where the shaft is free to rotate but the motor housing is not, ball bearings are used to connect the shaft to the motor housing. Depending on the application, different types of ball bearings are available to choose from. Advantages of ball bearings: good wear resistance. Do not need much lubrication, provide low friction, thus little energy loss. Long service life, easy to replace small general dimensions. Comparatively cheap, can handle thrust loads. Disadvantages of ball bearings: may break due to shocks, can be quite loud, cannot handle large weights. Deep groove ball bearings. This is the most widely used ball bearing type. Trapped between the two races is a ring of balls that transmit the load and allows rotational motion between the two races. The balls are held in place by a retainer. They have very low rolling friction and are optimized for low noise and low vibration. This makes them ideal for high-speed applications. They are comparatively easy to install and require minimal maintenance. Care must be taken during installation to prevent denting of the races, as they have to be push-fit onto shafts. Angular contact ball bearing. In this ball bearing type, the inner and outer races are displaced with respect to each other along the bearing axis. This type is designed to handle greater amounts of axial loads in both directions in addition to radial loads. Due to the shift in the inner and outer races, the axial load can be transferred through the bearing to the housing. This bearing is suitable for applications where rigid axial guidance is required. Angular contact bearings are widely used in agricultural equipment, automobiles, gearboxes, pumps, and other high-speed applications, such as CNC machining tool spindles. In this ball bearing type, the inner and outer races are displaced with respect to each other along the bearing axis. This type is designed to handle greater amounts of axial loads in both directions in addition to radial loads. Due to the shift in the inner and outer races, the axial load can be transferred through the bearing to the housing. This bearing is suitable for applications where rigid axial guidance is required. Angular contact bearings are widely used in agricultural equipment, automobiles, gearboxes, pumps, and other high-speed applications, such as CNC machining tool spindles. Self-aligning ball bearings. This type of ball bearing is immune to misalignment between the shaft and the housing, which may happen due to shaft deflection or mounting errors. The inner ring has deep grooves similar to deep groove ball bearings, followed by 2 rows of balls in the outer ring. The outer ring has a concave shape, and this grants the inner ring some freedom to rearrange itself depending on the misalignment. Thrust ball bearings. Thrust ball bearings are a special type of ball bearings designed specifically for axial loads. They cannot sustain radial loads at all. Thrust ball bearings exhibit low noise, smooth operation, and are capable of high-speed applications. They are available as single-direction or double-direction bearings, and the selection relies on whether the load is unidirectional or bidirectional. When to use ball bearings. So let's outline some of the working conditions that may require a ball bearing. Thrust loads are present. Ball bearings' design makes them capable of withstanding axial loads. No heavy loads. Due to having ball-shaped rolling elements, the bearings concentrate all the force onto a few points of contact. This can result in early failure with high loads. High speeds. The ball bearing's small point of contact also means less friction. So there is less resistance to overcome, and thus it is easier to achieve high speeds with these types of bearings. Magnetic bearings. Magnetic bearings use the concept of magnetic levitation to hold the shaft midair. As there is no physical contact, magnetic bearings are zero-wear bearings. There is also no limitation on the maximum amount of relative speed it can handle. Magnetic bearings can also accommodate some irregularities in shaft design, as the shaft's position is automatically adjusted based on its center of mass. Thus, it may be offset to one side but will still function just as satisfactorily. They are broadly classified into 2 types: active and passive magnetic bearings. Active magnetic bearings. Active magnetic bearings use electromagnets around the shaft to maintain its position. If a change in position is picked up by sensors, the system adjusts the amount of current being fed to the system and returns the rotor to its original position. Passive magnetic bearing. Passive magnetic bearings use permanent magnets to maintain a magnetic field around the shaft. This means there is no power input needed. The system is, however, difficult to design due to limitations, as this technology is still in its early stages. In many cases, the 2 types of magnetic bearings may be used in tandem, where the permanent magnets handle the static loading while the electromagnets are used to maintain the position to a high degree of accuracy. Plain bearings. A plain bearing is the simplest type of bearing. It usually only consists of a bearing surface. There are no rolling elements. The bearing is basically a sleeve mounted on the shaft, and it fits into the bore. Plain bearings are inexpensive, compact, and lightweight. They have high load carrying capacity. Plain bearings are used for rotational, sliding, reciprocating, or oscillatory motion. The bearing remains fixed while the journal slides on the bearing's inner surface. To facilitate smooth movement, material pairs with low coefficients of friction are selected. Different types of copper alloys, for example, are pretty common. This bearing can accommodate some misalignment, multi-directional movements, and is suitable for static as well as dynamic loads. It is used extensively in applications in the agriculture, automotive, marine, and construction industries. The gudgeon pin that connects the piston to the connecting rod in diesel engines is connected through a plain bearing. The spherical bearing is also a plain bearing, although it consists of 2 parts, the inner ring and the outer ring.